Lesson 6b, projectile motion of an object thrown straight upwards. Remember, a projectile is any object that travels through the air with no other force acting on it other than gravity. Throwing an object straight upwards. The object will slow down as it rises, stop for a moment, then start speeding up as it drops. As with all kinematics 11, we will ignore the initial force that makes the object shoot upwards, like the thrower or the cannon blast. In this scenario, the object travels in one plane, the y-plane, and travels in two directions, up and down. Now, since the object is initially moving upwards, it must have an initial velocity that is greater than 0. It's traveling upwards, so positive. Now, as the object travels upwards, it will slow down at a rate of negative 9.8 meters per second squared. So as it travels up, it will slow down and then stop. At the top of the toss, it will have a velocity in the y-plane that is 0 meters per second. It has stopped. As the ball drops, it will speed up at the rate of negative 9.8 meters per second squared. The velocity at the bottom will be greater in magnitude than 0 meters per second. Ideally, ignoring friction, the final velocity of the ball traveling in the y-plane downwards will equal the initial velocity upwards. In this video, you can see the tossed ball slowing down as it rises at the rate of negative 9.8 meters per second squared. At the peak, it stops and changes directions. As it falls, it speeds up at a rate of negative 9.8 meters per second squared. Under ideal conditions, the time to the top of the toss should equal the amount of time to fall back down to the origin. As you can see with the example on the right, the fellow tosses the ball with an initial velocity of 20 meters per second. If we round gravity to negative 10 meters per second, after 1 second, you'll see it will now have a velocity of 10 meters per second. After 2 seconds, it will now be 0 meters per second. After 3 seconds, it will gain negative 10 meters per second, and after 4 seconds, it will now be at negative 20 meters per second. The amount of time up equals the same amount down. Also, using our example, you'll notice that the distance up will also equal the distance down. Under ideal conditions, the magnitude of the initial velocity should also equal the magnitude of the final velocity. We'll demonstrate this to you later when we solve some problems. Given the above facts, you can solve these problems in two parts. The part where the object travels to the peak, arriving at 0 meters per second, or the part where the object falls from the peak, starting at 0 meters per second. To summarize, for vertical projectiles, initial speed equals final speed. The time up equals the time down. The distance up equals the distance down. The velocity at the top is 0 meters per second. Gravity is a constant at negative 9.8 meters per second squared.